So we're getting out our note sheets. We're on the very back. And we're going to start with problem number 7. Because this is one that we did a couple of yesterday. And so it shouldn't be too confusing for you. All right, so everybody is looking on our note sheet, back side, problem number 7. Now, remember I told you that you have until Thursday, test day, to have these formulas memorized. Hopefully, you're going to have them memorized sooner than that. But the two formulas we have are this one and our PERC formula. And we said this is the formula we're going to use anytime we have a money problem where interest is being compounded a certain number of times. So, like compounded monthly would be 12 times. Compounded quarterly would be 4 times. Anytime you have that kind of situation, this is going to be your formula. So when I read number 7, the key there that tells me this is the formula I'm going to use is the one that says compounded monthly. See that? When I see compounded monthly, compounded daily, compounded quarterly, that means this formula. All right, so let's read problem 7, and let's see if we can plug stuff in. We're definitely going to need a calculator for this. Let's see if we can plug stuff in where it goes. Well, what do I do with the 555 number? That's P. That's what I'm starting with. And this is a 1 plus. Did they give me an interest rate? Mm-hmm. What do I put in? Not 3.5, 0.035. Now, there's a denominator to that interest rate. What does the N stand for? The number of times we compound. So what does monthly mean? 12. So that's going to be a 12. Now, it's kind of unfortunate there's another 12 in the problem. The 12 years is this 12 right here. This is the time. So that's the 12 years. What is this 12 from? This 12 is from compounded monthly. That's what this 12 is. So in this problem, if it had been compounded quarterly, that would still be a 12 because it's 12 years, but these would be 4s if it were compounded quarterly. Do I need logarithms to solve this? No. Boys and girls, let me say it again. Abby Brady, listen. We only need logarithms when our variable is up here. Our variable is not up there. So we don't need logarithms. We're just going to type it in. So we have 555. 1 plus 0.035 over 12 to the 144th. I like to clean that exponent up before I get started. Now to type this in, let's all do it together so we get it right. Let's type this right here on our calculator. So type 1 plus 0.035 divided by 12 equals. Then we're going to raise that, using this button, raise that to the 144th equals. Then we're going to take that answer times 555 and tell me if you got $844.17.
Yep.
Wait, 840.
Now, I am not trying to trick you, but I need you to look at problem 4, and we need to talk about something. Problem 4 uses PERT. Now, I know what you're thinking. You're thinking, wait a minute, Mrs. Ford, number 4 is a money problem, and it says compound it. So why is this a PERT? Well, how many times am I compounding? You know, when it's monthly, it's 12. When it's quarterly, it's 4. This one is continuously. That's a problem, isn't it? Because if it's continuous, you don't have any idea what to put in for n. So we're going to use this formula if we are compounding continuously. All right, again, not trying to confuse you, it's just the way it is. When do we use this formula? When we're compounding a certain number of times, monthly, daily, yearly. When do we use this formula?
Compound continuously.
When we're compounding continuously. All right, so here we go. I'm on problem number 4. How much do I need to deposit in an account paying 4% compounded continuously if I want to have $35,000 in 10 years? Where do I put the $35,000? A. That's what I want to end up with. So the $35,000 goes in for A. That's what I want to end up with. What do I put in for P? Nothing. That's what I'm looking for. That's the question. E is E. E is not a variable. You don't plug anything in for E. It's just E. What's my interest rate in this problem? 0.04. Very good. Never say 4. Never say 4. It's 0.04. And what's my T? 10. So like before, I like to clean up my exponent before I get started. So that'll be e to the 0.4 when I multiply my 0.04 times 10. Now, if I want p by itself, kids, I need to divide both sides by this e, right? So P will equal 35,000 divided by E to the 0.4. That's what I'm going to type in on my calculator. So let's make sure we all know how to do that. I don't want to have to say this too many times. So get your calculators out. Okay. We're going to type 35,000 divided by, all right, now listen, second ln. And then you got to type 0.4 because that's your exponent. I didn't get a weird number. I got 23461.20. All right, so if you did not get that number, if you did not get this number, then I want you to stop right now. And I want you to type exactly what I tell you to type. 35,000 divided by second ln 0.4. And you should have gotten 23,461. Now, I'm giving you the keystrokes for a graphing calculator. That was the calculator you're supposed to have, supposed to be using. If you're using a different calculator, it might have different keystrokes. Not my problem, that's yours. Now notice, did I use logarithms to solve that problem?
No.
No, why not?
Because you didn't have
Because my variable was not in the exponent. This is where your x or your t or something has to be if you're going to use logarithms. Number 8. I know we're skipping around a little bit. That's how we're doing it. Number 8. What interest rate compounded continuously? Okay, wait a minute. What formula? PERT. Will be required to end up with $1,000. Now, where am I going to put the 1,000? That's A. That's what I want to end up with. Remember, this is the end. After 3 years, if $890 is initially deposited, where do I put the $890? That's P. And T is 3 years? Oh no, oh no. Where's my variable? In the exponent, which means eventually, not step 1, but eventually we're going to use logarithms. Because there's your variable up high. And we can't do it up high, we've got to bring it down, so we'll use logarithms. But before we do anything else, there's a first step. What do you think? Divide by 890. So we're going to have 1,000 divided by 890 equal to e to the 3r. Now, that exponent's up high, it's got to come down. The only way you can bring it down is to have a logarithm in it, right? So we're going to take ln both sides. Why am I using ln? Because there's an e. It's going to get rid of the e. There's an e in the problem, and ln's going to get rid of it. This is going to be gone, and all I'm going to have is ln 1,000 over 890 equal to 3r, because that's gone. It's the beauty of ln. It cancels out the e. All I need to do then is divide by 3. So if you think you can type that in, go ahead and do it. If you want my help, I'm ready to give it here. I'm going to press ln. These parentheses will automatically come in, so I'll just do 1,000 divided by 890, close the parentheses, and then divided by 3. So the answer is 0.0388, which would be about a 3.88% interest rate. Remember, the question said, what is the interest rate? So it's about 3.88%. How are we doing, okay? Now I want to look at number 6. Now number 6 is a population problem. It isn't even a money problem. If it's a population problem, it's PERT. The other formula is only used with money. So if it's not money, it's automatically PERT. Okay? Let me say that again. If it's not money, it's automatically PERT. And in fact, it's PERT in what kind of money problem? There's one kind of money problem where it's PERT. Compounded continuously. Very good. Okay, which one did I say? Number 6. What do I do with the 193? That's P. That's my starting amount. What's my ending amount? 391. What's my R value? 0.222. Oh, shooty tooty. Look where the variable is. What does that mean? We're going to use logarithms at some point. Not first. What happens first? Divide. So we have 391 over 193 equals e to the 0.222t. Next step, ln both sides. Very good. What's going to happen over here on the right when I ln e to the 0.222t?
E goes out.
These are gone, and I'm just going to have 222t. You good with that? So my answer, I'm going to divide by 0.222. So my answer is going to be ln 391 over 193 divided by 0.222. So go ahead and type that in if you know how. If not, I'm going to tell you. ln 391 divided by 193, close parentheses, divided by 0.222. And it's about 3.18.
Yep.
And if I have a unit in there, no I don't again. So I don't know if that's 3.18 days or 3.18 years or hours. It's a unit of time. All right? Well, there's only one left, groupies, and that's number 5. Here we go. Is number 5 a money situation? No. Therefore, we know it's a PERT. This is a little bit tricky, but I think you can get it. Who can tell me what half-life means? It's from chemistry or biology. Yeah, so in other words, if you started with 10 grams of it, it would be the time it took you to get down to 5. Right? Half-life. We were going to cut it in half. Now, did they tell me how much I started with? Read problem 5. Did they tell me how much I'm starting with?
No.
No. I just know that however much I started with, I'm going to end up with half of it. So guess what? You get to pick a number.
Any number?
Any number. So let's suppose we're going to start with 100 grams. We're going to start with 100. How many would I have to end up with? 50. Now, we need to pick something and go, so I started with 100 and I'm going down to 50. Could Jared have started with 10 and gone to 5? Yes. Could Abby have started with 18 and gone to 9? Yes. It doesn't matter. Pick a number to start with, and then you'll end with half of it. Now, what else do I know? I know the time period is 10.2 years.
Is it easier to go with the smaller numbers? Or does it make
Well, it's not going to make any difference, Katie, because what's step 1?
just
Divide. And what's going to happen when I divide? No matter what numbers I have, when I divide, what am I going to get here? 1/2. Because if you would have started with 5 and 10, or 9 and 18, when you do the division, you're going to get a half here. 0.5, 1/2. What do I do next? ln. What happens to my ln and my e? They're gone, right? So my answer this time is just going to be ln 0.5 divided by 10.2. Now, this is going to be interesting. Go ahead and type this in, ln 0.5, close parentheses, divided by 10.2. Did you get a negative number? Can you explain that to me?
It's decay.
It's decay. It's negative growth, right? When you put money in the bank, that's a positive growth because you get your money just keeps building, building, building. But radioactive decay, the thing is getting smaller, so its growth is negative. Got it?
Yeah.
All right, well, you did some pretty heavy-duty stuff today. I'm proud of you. Good job.
Yay.
All right, now what we need to do